which is somewhat being understated by the press. But if you read the really serious books on this subject, the implications for this is phenomenal. The discovery recently in terms of the superluminal speed of these muons that was discovered before Christmas, the implications for this are phenomenal as well, because it suggests that Einstein's barrier on light speed suddenly doesn't exist anymore, which of course would explain some of the phenomenon that are seen, such as superposition and entanglement. This suddenly could explain why we can have instantaneous communication between subatomic particles. And this is simply because, of course, everything is a oneness. The reality that we perceive that is separated, in the terms it is separated by geographical space and such like, in fact is an illusion brought about by the human mind. Space is not as it seems, as time is not as it seems. What we're doing is we're discovering now that consciousness, other than being just an epiphenomenon of the brain, is actually central to everything we perceive around us, which, of course, Niels Bohr suggested back in the late 1920s with his Copenhagen interpretation.
Well, exactly. That was one of the points I want to try to get to here, that it seems like we've gone on a little detour science overall, Anthony, and finally now we're catching up to some of the ideas that were out there in the early 1900s or so, and we're going back to that now, basically. That's what I see anyway.
Very much so. What is happening is, I think the issue has been that the sciences such as biology have rather fallen behind in terms of quantum physics. And of course the reason for this is quite logical, because particle physics is illogical. It is not common sense. It doesn't fit in with our overall comfortable Newtonian worldview of cause and effect. It doesn't work that way. You can have particles in two places at the same time. You can have particles instantaneously communicating. For instance, I was surprised to discover that a guy called Anton Zeilinger, who works at the University of Vienna, has been working on particles where he's entangled particles, and then he's bounced these particles off low-lying geostationary satellites in space. And these particles have shown again, as they've regularly discovered, that if you take one action on one particle, the other one instantaneously reacts. Now, many traditional scientists will say this is a misinterpretation of the facts. They will argue that it is mathematical equations and that people like myself are misinterpreting this. This is not the case. There was Bruce Rosenberg, who is professor of physics at the University of Los Angeles, wrote a book 3 or 4 years ago called Physics Encounters Consciousness, I think it was. Mm-hmm. And in this, he discusses in great detail and stipulates quite precisely that it's not a misinterpretation. The fact is that quantum physics suggests a reality that is counterintuitive, but is the opening of a completely new science. And indeed, one of the areas I'm quite intrigued with at the moment is something called Bose-Einstein condensates, and the implications for something called the zero-point field, which I'll come on to slightly later. But effectively, all these things suggest that we are on the edge of radical new discoveries in terms of science, radical new ways of understanding consciousness. Because after all, whenever I discuss these things with materialist scientists and materialist reductionists, I always make the point, and it's not an original point, but I still think it's a very valid one, that materialist reductionist science is the science of taking things apart in order to understand how they work. So, for instance, if I want to understand how a motorbike functions, I take it apart and I take the engine apart bit by bit and then put it back together again. And by doing so, I will understand how the engine works. But this is analogous in many ways to what we're doing with particle physics, in the sense that there's another thing, that you take a motorbike apart in order to discover the speed. And of course, you're not going to discover the speed by taking it apart, because the speed is an epiphenomenon of the motorbike. It's a secondary factor
right.
of the motorbike.
Yeah.
And this is the same with consciousness in the brain. If you take the brain apart, and we look into the brain and we look into the neurons and we look at the neurological pathways, we can do CAT scans and we can do MRI scans that will tell us exactly which parts of the brain fire up when certain thoughts are thought and when certain motivations take place. We can probably understand which parts of the brain do what. But in none of this analysis have we ever been able to analyze a thought, an emotion, the substances that philosophers have long discussed, this concept of qualia, the concept of the intensity of red, the concept even of pain. You know, effectively, if I have a pain in my finger, you could take my brain apart till the cows come home, but you still won't find the location of that pain.
Right.
Because pain does not exist unless there is a person perceiving that pain. Now, you can extrapolate that and say that in which case, everything we perceive in reality out there is in one way or another a qualia. It is something that is created by the brain to be presented to a consciousness. Without the consciousness perceiving it, there isn't the external universe. We're drawing up information, as Professor Ervin Laszlo did when he took the ideas of David Bohm. Laszlo and Bohm say that everything is digital, everything is energy. All that happens is the human brain processes that information and creates a three-dimensional external reality that seems to be solid. But of course, as we discovered when we had our 2-hour discussion with Tom Campbell, taking that to its logical conclusion doesn't work. Yeah. Because reality, when you take it down to its component parts, is 99.99999% empty space, and what is left is in fact vibrations within a field. So there's nothing out there.
How much would you say that we are creating then? If we're looking for this, is obviously this is a fascinating riddle, Anthony. I mean, if we create reality and yet we're trying to find the root of it, what are we going to find? We're going to find ourselves there in a way, kind of looking for these riddles and try to solve it. And whatever we project, or maybe what we even think we might find out there, might be something that echoes back to us. Is there a way that we really can get to the root of it, or is the nature of reality so elusive, such a mystery that we can't nail it? What do you think?
Well, there is an argument that is used many, many times to say that anything that exists within a system cannot ever understand the whole system because we're part of it. In other words, you know, I recall, and I'm reminded of the famous Abbott book about Flatland. You know, the book written around about 1854, I think, by the school teacher, and the idea that that we cannot perceive. If we are three-dimensional beings, we can't perceive a universe in 4 dimensions. In other words, we can't even necessarily perceive a reality if we bring time in, that Minkowski suggested in his terms of his block time concepts. But indeed, there are now supposedly many more dimensions wrapped up within themselves. If you listen to string theory, they will argue that there are many, many more dimensions of reality. But if we can't perceive these realities, and the instruments we design can't perceive these realities, these will forever be hidden to us. You know, we will never necessarily understand them. The only way we can extrapolate the information is by either using mathematical models and mathematical language, or else we need a radical rethinking of exactly what we think reality is. Now, I believe that the secret lies in the concept of 0-point energy and the 0-point field. I think this is where the answer may lie. The idea that empty space and the reality we perceive out there, when we perceive it to be a vacuum, is in fact the complete opposite. It's a plenum. It's absolutely full of energy. And this energy is, we attune into this energy like vibrations, like, you know, the way in which a string vibrates depending upon how it's energized. And I think in some way the human brain picks up this energy form. Now, if this is the case, there is a suggestion to say, and again, I'm not original on this, it was very much suggested by Ervin Laszlo, and if you go back to David Bohm and people like that, it's something they've been talking about for a long time, that reality itself and consciousness are all part reality. In other words, when you look at the philosophy and the philosophical arguments about the nature of consciousness and reality, we fall into the trap of dualism, the Descartesian dualism. And the idea that either there are 2 substances in existence. There is physical matter and there is thought. The question has always been, how does thought influence matter? And it's a very intriguing point, because it's the idea of, I choose to move my arm, or I'm choosing at the moment to move my larynx in certain ways in order to have the air run past my larynx so that I can make sounds and I can communicate those sounds. Now, what is happening here is my brain is doing this. And my brain is doing it by sending signals from my brain to my larynx to make it move in a particular way. However, what is making the brain do that is whatever I am in my head. Now, I'm a non-physical thing. You know, my thoughts are non-physical. My consciousness is non-physical, as we discussed before. And the question is, how does something non-physical become the motive force of physical action within the universe? And this is
unless, of course, our conception of what is physical is faulty or erroneous.
Correct. And this is the point I'm going to make, is that what we're doing is we are observing two phenomenon that we think are different phenomenon. And it reminds me of a wonderful story that David Bohm once used when he was trying to explain how two particles can seemingly be seem to copy each other in terms of movement. Because what has been noticed is that if you entangle two particles and you spin them off into different directions, it's something called the Einstein-Podolsky-Rosen thought experiment, but effectively it was proven scientifically by Alain Aspect in 1981 using something called Bell's inequality. I won't go into the details of that now. But basically what they find is that if you have two particles, you entangle them, you do one thing to one particle, the one reacts immediately. Now, David Bohm used a wonderful example in his book, The Implicate Order, where he said, imagine a scenario that we are in communication with an alien species that are thousands of light years away. And there is some way that we can communicate with them by sending them pictures, which they get instantaneously. The process is immaterial. We know that's impossible, but just bear with me for this for a second. So what the people on Earth do is there's an aquarium, and there's one fish in the aquarium. And what they do is they place one video camera at the front of the aquarium and another one at the side. And they send two signals to our alien friends. And the alien friends have two television screens. And they've never seen a fish before. And because the cameras are filming from slightly different angles, there is no immediate way that you can tell that it's one fish. You assume it's two, because the fish will move in different directions because the camera angles are different. So the aliens will assume that there are two particles. However, a very, very bright alien notices that there's a relationship. When one fish moves in one direction, the other one seems to move in a different direction, but there seems to be a relationship between the two. They seem to be communicating instantaneously. And again, rather like the scientists on Earth when they discovered superposition, they thought, this is quite strange. Why does this happen? But at a lower level reality, one of the aliens points out that maybe we are looking at one fish from different angles. Now, this is what might be happening with subatomic particles, in the sense that at a much deeper level of reality, what we consider to be two particles are in fact one. Now, if we're discussing this in terms of electrons, it's logical to conclude that every electron is related to every other electron. Now, you may or may not be aware of this, but one of the greatest theoretical physicists of the late 20th century was a guy called Richard Feynman. And Richard Feynman once suggested in a lecture that the reason that we see these things the way we do is that the universe consists of literally one electron moving at infinite speed, in which case everything that we perceive is related. And of course, this is exactly what David Bohm said, that we're perceiving reality in a completely different way. And of course, this goes back then to the Hindu belief systems, the Buddhist belief system about the oneness, that there is no duality. Everything is non-dual. So in which case, the real reality behind the reality is a oneness, a timeless oneness. Now, again, it was an intrigue. I had an intriguing meeting with Professor Jeff Forshaw, Now, Jeff Forshaw is the youngest British professor of physics, I think, in history. And he has the chair of physics at Manchester University, indeed in the same building where Rutherford split the atom. And one of his PhD students is, in fact, Brian Cox.